Hi guys, today's topic is WebSockets and system design. So, have you guys ever sent a message on WhatsApp and wondered it actually gets delivered instantly, right? And or watched any stock prices update in real time without actually you refreshing the page? For example, if you guys must have used something, you must have used Grow application, right? Now, what makes this possible? Like the traditional requests, which follow the typical HTTP request response model, they struggle with real-time updates. But WebSockets actually provide a solution. Now, in this video, we will actually break down WebSockets, the technology that powers the real-time chat applications, stock market updates, and multiplayer games, and so on. Now we'll explore how WebSockets work, compare them with the traditional HTTP requests, and discuss where they actually fit into system design. Now, by the end of the video, you will know that what WebSockets are and how they actually work compared to HTTP, right? And how WebSockets establish real-time, bidirectional communication. And I'll also discuss the common use cases like chat applications, stock trading, live streaming, etc. And also the advantages, limitations, and when to actually not use WebSockets. Now, I want you guys to understand the premise of why exactly do we even have uh, WebSockets in place, right? So, traditional web communication rely mostly on HTTP, which follows a request response model. That is, once the client sends the request, so server responds back to the response, and that's it. So this is the request, we get a response from the server, and this is it. So the connection is closed after the response is sent. Now, what are the limitations, right? So if you think about it, one of the most important limitation is one way communication, right? So the server can't give you constant response. There's just that one response at a time. So the server can't push updates unless the client requests them again and again, right? Now, also, if you want, let's say, even if you want multiple responses from the server, you would have to keep repeated connections again and again just to get the repeated responses. Now, also, what this introduces is something called as high latency, right? Now, live data updates, if you really want to achieve live data updates, right, you will have to do this multiple times. Now, let's assume this first request itself takes around, maybe in very realistic scenario, maybe 1 ms. It's a very lightweight JSON request, and the response also maybe completes in 1 ms, 1 millisecond, right? It's a very lightweight operation, let's assume, right? Now, this is just for one operation. You're taking 2 ms. Now, if you really want live updates, right, you'll have to keep doing this x number of times. So basically you'll have to wait for 2x amount of times if you want x operations to be completed, right? Now, this is a very, so let's imagine a stock market application, right? It uses HTTP. Now the client has to keep making new requests every second, right? Or every second, or how much ever fast we want to make it, just to check for the price update. Now, this is very inefficient and slow. It of course uses up many resources of the server, of the client as well. As now, the client is always going to be light, right? Now, let's discuss about what are WebSockets, right? Now, till now we had discussed long polling are inefficient because of real-time updates. What does it mean by polling? Polling is constant requests waiting for a response. So you'll keep making requests as a client, and you'll keep accepting response. So that is like constant requests to the server. So uh, client will have to poll the service for a response. So polling is nothing but just constantly interacting or requesting data from server, right? Now, let's discuss about what are the WebSockets and how do they work, right? Now, now I want you guys to just visualize what would be the difference, right? So unlike HTTP, WebSockets actually allow something called as bidirectional data share. That is, so let's say a client sends a request to the server, and so there is something called as handshake. So the client initiates a handshake by sending an something called as upgrade WebSocket request. So it is something, there is a confidentiality, right, between client and server, how you want to actually have a WebSocket connection. So something like upgrade equals to WebSocket is sent, so something like this, upgrade is WebSocket request is passed in the request, right? Now what happens, now the server responds. So this is how the traditional WebSockets work. Obviously there would be a lot of abstractions could be done and stuff. So the server responds with something called as 101 switching protocols. Basically what it means is, it means that server has acknowledged that it has received a WebSocket request, and it has established a persistent connection with the client as well. Now messages, because of this, right, now messages can now be sent in both the directions at any time without actually reopening the connection. Now that is the main advantage. And also I would also say that it is also a bit of overhead than a typical request response, right? So this handshake in between is something adding to the overhead. It's an overhead as compared to just sending request response. But what is the advantage of having us a bidirectional connection? That is, client can keep sending requests and server can keep responding without actually breaking down the connection again and again. Now I want so I think this HTTP in itself, they use something called as HTTP protocols, right? So something like, I'll write it down. So something like this. So this is the HTTP protocol that I think you guys might have used if you want to visit a website or whatever, right? What does actually WebSocket use? They use something called as WS protocol. So WS is nothing but WebSocket over an uh, unencrypted connection. What I mean by that is, I think you guys must understand that. So for example, what I mean is, so unencrypted. So in the same terminology of HTTP, right? So HTTP is nothing but HTTP connection over an unencrypted connection, just like WS this. Now the same thing we will have in over a secure TLS connection, right? So something corresponding to HTTPS is nothing but WSS. Now let's take an example to which you can relate, right? Now when chatting on a WhatsApp web, you don't need to hit refresh to see new messages flowing in, right? So just imagine that web the web the WhatsApp web is your client, right? Now if you think about it, if you just just keep your uh, WhatsApp open, right, and just ask your friend to send a message. Now if you notice, and I think you guys might have already know this, but I want you to understand and feel the concept, right? Now if you guys might have noticed that, let's say if your friend sends a message, you need not refresh your page. That is, there must be something that is persistent between the client and the server. So what happens, I want to explain you guys via the diagram. So this is, for example, this is your friend, right? Now this guy sends a message, and that is stored in the server. Now here is where you are sitting, right? And here you have already established a bidirectional connection. That is, so whenever you get a message, you instantaneously get a data back, right? That is because of this persistent WebSocket connection. right? That is the beauty of it. Now if you imagine the same, right? Now if you imagine the same, that let's say your friend had sent at around, let's say, 10 a.m. He has sent, let's assume that WhatsApp uses HTTP connection, right? Now he had sent you a message at 10 a.m., right? And you had refreshed or loaded your WhatsApp web around, let's say, 9:55 a.m., right? 9:55 a.m., right? Now what happens? Now what this means is you just request at 9:55 for the data that you have received to this server will say you don't have any latest messages, right? Now let's say you again, you will have to request the data at around 10:05 am, right? Now at 10:05 am, at 10 am your friend has sent the message. At 10:05 am your server has the message that you have to receive, right? Then server would be able to respond back. So what does this mean? Isn't this a literally the overhead, and it just literally destroys the purpose of having something called as WhatsApp, right? If you really have to log into WhatsApp every time just to see your messages, and what's even the point, right? You can just have a letter being sent, correct? So that is all about it. Now I want you guys to really think about the application, the example which I've given to you guys, right? Now just think about how and where can WebSockets or consistent, persistent connections can be used, right? Now WebSockets shine, they are literally made for applications that require real-time, continuous data exchange. For example, live chat applications like WhatsApp, Slack, Discord, they use WebSockets for instant message delivery. Stock market trackers, of course, they do require live price updates for stocks and crypto exchanges. Multiplayer games, live streaming, and video calls, etc. And there's also one important example I think many guys are also interested in, like the system design of Google Docs, right? So if you are, let's say, collaborating with your team on something like Google Doc, right? Now if you don't have WebSockets and someone is updating something in real time, and if you don't see it, then what is even the point of having Google Docs, right? You can just write it on a sheet and just then share it to your manager XYZ. So unless it's collaborative, it defeats the whole purpose, right? That is the overall picture of WebSockets, and why is it even considered a game changer in my opinion for many of the applications that are used currently. Right? Now I'll tell what are the advantages. Advantages are, it basically has this full duplex connection. So you guys, when let's say you read through any documents or books, you would say that many people refer the WebSockets as full duplex, as WebSockets having full duplex connection. Both client and server can send data and messages at any time, right? Now of course, this what it means is there is no overhead of constantly polling or constantly asking for data from clients. So what it essentially means is it reduces the latency, and it is also a very firewall friendly. That is, so if we read through more depths of how WebSockets are written and understood, they actually use HTTP ports as 80 and 443, which actually are very firewall friendly. They avoid security issues and so on. I don't want to go into details, but this is a very high level and really oblique understanding I want you guys to have from the system design perspective. Now what are the challenges of WebSockets, right? Advantages are great, that's what we want to know, but what are the challenges of WebSockets, right? Now some proxies, so there are lots of proxying issues. That is, let's say some proxies don't support WebSockets, requiring additional configuration. That is, proxies, I think, I don't want to go into detail. It's something like it's it's sitting. So what is a proxy? Proxy is nothing but something that is sitting in front of a real system or client. So let's say this is our client, right? Now this is one proxy which is actually interacting with the server, right? Now if now server actually only knows that uh, knows the address of some xyz, but it just knows the address xyz, but it doesn't actually know to which system it is interacting to. That is where proxies come in. I don't want to go into detail, but so there are lots of challenges in persisting such WebSockets when we have proxies in place. And another thing is load balancing complexity. Not all proxies, as I said, load balancer is nothing but a proxy, right? If you think about it, this is the load balancer, these are our servers, for example, these are our clients sending data. Now when it has issue with actually setting up proxies, it also means that load balancing is also very much challenging, right? And one of the main important uh, disadvantage of having WebSockets is its stateful nature. That is unlike REST APIs, which are actually stateless, right? WebSockets maintain state, making scalability more complex. Now how do we actually scale WebSockets? I've talked like there are scalability challenges. Now what are the general practices, right? So some companies obviously would have overtaken these challenges already. That's why they are where they are, like WhatsApp, stock trading companies, and so on. So very common solutions that are used in industry for WebSockets are using load balancer like Nginx, such a proxy to they actually provide the management of WebSocket connections out of the box. You can also implement Redis or Kafka to synchronize data across multiple WebSocket servers. So there are lots of see, once you persist the data, what happens is across different entities, your data will become challenging to maintain the data, right? So let's say if you have multiple replicas of a server, and one client is always talking, is having a WebSocket always to this server, right? And it is always dumping the data. Now if you think about it, if you have replicas of these servers, how do you maintain them? You will also have to again introduce an additional sync between these both, and so on. There would be, if I really want to have a session with you guys, I'll have it lots and lots more such interesting issues, but I don't want to stretch a lot, right? Okay, let's go forward. So when to actually use WebSockets, right? All this is fine. So we should actually use WebSockets when your app requires any real-time updates. You need low latency, continuous communication. Also, when you're building something like a multiplayer gaming or multiplayer games, right? Valorant, CS:GO, and so on, and collaborative tools like Google Docs and so on. Right now, why should you actually avoid WebSockets, right? There is, as you guys might have seen, so there is of course an additional challenge of having this handshake. This actually adds to nothing but an overall management complexity, right? Having this persistent connection which actually clogs up your resources, right? Now why should you then avoid WebSockets? If your app primarily follows a request response pattern, if REST APIs actually work better, please use them. You only need one-way streaming, that is, you don't need data to be exchanged between client and server again and again. Then just don't use your WebSockets, right? It's just an overhead of maintaining a bi-directional connection all the time. It just eats up resources. There are lots of network challenges in having that, and so on. And if your application of course doesn't need any real-time updates, then why do you even need it? Just use REST APIs. They're very much scalable, well proven, well organized, and so on, right? Now I want you guys to understand what are the summaries and what are the key takeaways if I want to summarize everything I've spent the time on, right? Now, in short, WebSockets allow real-time bidirectional communication over a single connection. They are useful for live chat applications, stock trading, gaming, and collaborative editing. Now, unlike HTTP, WebSockets maintain a persistent connection, reducing overhead. Now, while powerful, WebSockets do introduce multiple challenges in scaling and state management. Now, use WebSockets when real-time interactivity is only required, but avoid them for simple request response, uh, API requests, and so on. Now, that is all about it from system design perspective for WebSockets. Please do subscribe and please do share with your friends who might find this helpful and are preparing for system design interviews. Thank you guys. Have a good day.